5 common mistakes you want to prevent installing automation devices in your distribution grid. This is Power Grid Expert, the YouTube channel about distribution grid technology. If you like this video, click the follow button and subscribe to my YouTube channel. We are talking about automation devices for the distribution grid. So what are these devices? We are talking about protection relays, we're talking about fault indicators, about earth fault indicators, we are talking about measurement devices, about remote controlling the switch in a switchgear from a substation, in a substation, and so on. And all these devices have one thing in common. First of all, they are needed and they will be needed much more in the future. The transition of the distribution grid towards green energy supply is taking a toll, and the toll means we need much more control, much more visibility within the grid. And the second thing is all these devices normally have somehow some kinds of sensors for voltage and current, and they need to be installed, and they need to be installed correctly. And in this video, I give you a little insight on my last 18 years experience. I've been called to many installations to check the installations. Most probably when it's too late, because when there is a fault in the grid, like a fault, like a short circuit or earth fault, and the device didn't work properly, and then you have to look for the root cause. And to prevent this hassle, this video should give you some valuable clues which mistakes should be prevented. We are talking about distribution grid automation. So here's an example from a switchgear in Germany. What we can see here is an SF6 switchgear, medium voltage, 10 kV, 20 kV. There's voltage indicators, there's fault indicators, there's somewhere a remote control unit. And these devices built in the switchgear, they have sensors, and sometimes you have to retrofit them, sometimes it's a new installation, doesn't matter. Sensors have to be installed somewhere, and this is what it's all about today. First mistake, not taking care about the start point grounding while choosing the right device. To be honest, this is less and less important because most modern fault indicators, most modern protection relays can deal with all kinds of start point groundings, low ohmic terminated compensated networks, and much more. But it's a good idea to check if you are on the safe side with your device. So what we're talking about the start point grounding, and in this case distribution grid. So we talk about the start point on the secondary side of the high voltage transformer. An example is given here. So you better check your start point grounding in your network. Is it low ohmic? Is it isolated? Is it compensated? Does it have a Peterson coil? Most probably not, because that's a specialty in Central Europe. But anyway, have a look at it, be sure about it, and be sure and get a confirmation, if you are not sure, from the producer of the device that it suits your network. Ignore the type of cable termination is the second mistake. And the thing is, the distribution grid is a living organism. So a transformer easily lives 30 years, 40 years, maybe even longer. And technology takes steps in these times, and technology changes in decades. So that applies also to the cable and to the cable terminations. In former times, the isolation of the cable has been done with oil-filled paper isolated cables. Nowadays, it's normally it's simple plastic cables. Then it's less important, but be aware of what you have. For example, we have here in this picture an example of cable termination single core cable with oil, and this oil reservoir here is only isolated, it's not screened. And whatever you do with your sensors, we're talking here especially about the current sensors, whatever you do, be sure not to install them just on the isolated part. The isolated part is not screened, it's not made that anything is installed here. Maybe you can install and it looks fine, you close the door of the switchgear and then partial discharge slowly appears, and after some time you have an earth fault. Of course, that is what nobody wants. So be aware where to install those sensors. Always go on the screen part of the cable. That's another example. This is a quite modern plastic cable, 3-core. So we see here the 3-core cable coming in, then there is the 3 phases are coming out. Here you can see there are still screens, so no problem here. You can install them easily on that part. And that's the most modern and most common version. Elbow plug, plastic cable, black area here with a screen, no problem to install. The variants of these cable terminations are nearly endless. I cannot give you all the examples here, but you can keep in mind that installing current sensors, as long as they are not specified to be installed directly on potential, always put it on the screen part of the cable. And here we are with the screen. Another big and common mistake is the screen feedback. And even myself, looking at installations, sometimes it's hard to find the mistake. But this is something that has to be checked, and it has to be done correctly, because there is no device on this world that can test about the correct installation of the screen feedback. You have to have a look at it, you have to concentrate, and you have to make it the right way. So what is the right way, or what is the idea behind the screen feedback? If you look at the medium voltage cable, we have the core, there's the load current and the fault current, and there's the screen around the core. In the core, we have the load current, the fault current. That is what we want to measure with our CT. But also in the screen, there is something going on. There is different currents in different directions flowing depending on the situation in the network, depending on the installation. This is what we don't want to measure, and this is what we don't want to see. So the thing is, if we install the CT around the cable, we will measure the vectorial sum of both these currents, but we only want to have the core current. So what we do, you see here the screen is coming out of the cable. This you see here on the photo. And then it's very important to go straight back through the CT and then earth the screen. You can see here this earthing bar. And you see here the screens are going back. Here the CTs going through the CT and then are earthed. This is the correct way, because then all the currents that are flowing here are subtracted by the screen feedback. So this is null, and we only measure the core current. Also be aware that this is blank copper, so don't make any loops here that might contact here the earth part of the switchgear. Then in this case, it looks good. It's correctly installed, but touching something metal earthed up here, the effect is zero. There is no feedback through the CT in that moment. The current goes there. Also what we don't want. Also don't go outside of the CT and then back through, then you're double the mistake. Also not a good idea. Just think about subtracting what is flowing in the screen, and then you will be good to go. Ignoring environmental and EMC conditions in the substation. We are talking about substations out in the nirvana, out in the desert, out in the wherever the climatic conditions are harsh. We are talking about worst case -40 to +50 in the environment. So be sure that inside the substation, it's getting even much hotter. The devices you install there, they have to meet these criteria. Once again, common products made for this purpose are made to deal with these environmental conditions. If you just pick a normal industrial solution, it might be not. So be aware of that. Also, humidity is a big issue. The substation is on the ground. From down the ground, there's always humidity coming up. And electronics is sensitive to humidity, so it has to be protected also for those cases. EMC conditions is another aspect, and also again here, standard devices meet those criteria. If you take a normal industrial product, it might not be able to cope with those EMC conditions out in the transformer station. For example, during installation, you switch on the transformer, the medium voltage transformer. The low voltage side is used to power your measurement device, and while switching on, you have a big surge here in the auxiliary voltage. And modern electronics, once again, is sensitive to EMC, so these devices have to deal with that conditions as well. Yeah, nearly the most important thing, installation without counter check. I've seen it many times that people believe in what they are doing, which is great because you have to be confident in what you're doing. But always be aware that you need a counter check. If we're talking about a very simple clip-on fault indicator, non-directional, there are not many things that can go wrong. But if we're talking about directional measurement, you can put it on the wrong phase, you can put it upside down, you can have a cable interruption between the sensor and the device, and all that can lead to wrong fault indications, to wrong measurement values, and worst case, most often you will not see that during normal operation. You will see that mistake in case of an earth fault, in case of a short circuit, and then those devices are pointing you towards the wrong direction, towards the wrong location of the fault. And of course, these faults always happen Saturday night at 11, and the people who have to go out and to look for the fault, they are stressed, of course, because you want to switch back the power on as soon as possible. So if you're dealing with wrong indications in that case, this is not a very nice thing. So be aware that everything has to be checked. The best way to do it is a simple primary test. Make a loop through the CT, put some current through, make the same with the voltage. Check in the measurement indications if it's the right phase, if it's the right direction of what you are expecting. And you do that with all three phases, and then you're good to go. Also, be sure to put the right set of parameters. So for these devices, we're talking about protection relays, fault indicators. They have settings for trip currents, for delay times, for types of faults you want to check and you want to detect. So be sure to put the right parameter set on those devices before leaving the station. And also, if there is an RTU installed, if there is communication installed, you can also, and you should definitely check the communication. So to make the line, to the chain complete, start with the sensor and in the SCADA center and check really the whole chain. Best thing to do is really to release a test message for every case you want to report to the SCADA center, and get a confirmation from the guys in the SCADA center that the right indication there pops up. And then you're absolutely sure. It sounds a bit complicated, but once you have routine in that, it's not easy peasy, but it's compared to the whole installation, it's quite short and gives you a peace of mind that you installed the device in the correct way. Last but not least, engage your people. Train the guys who have to use those devices. They have to be confident in how to operate the fault indicator, the protection relay under normal operation conditions. They have to absolutely know how the device indicates in case of a fault, what is the how to follow the directional indications. If you're not confident in that, you're stressed, and again, stress in those situations is a bad thing, so we want to prevent it. Practice. In my experience, one training is unfortunately not enough. You train, and then if you have a modern cable network, nothing happens maybe for 2 years, and then it suddenly happens, and then everybody is chickening out on how to find the fault location. Plan a regular schedule, a regular training, like once per year. Catch the guys who are operating those devices under normal operational conditions and also in fault conditions, that they have a certain routine in how to use the devices, that they are really helpful for them. That's it. Those are the 5 most common mistakes. Now you will prevent them. If you like this video, please click the subscribe button down below and follow my channel. Thank you for watching.